Greetings, fellow meccas. Today we'll be looking at an abatement cost problem. The problem. The objective of two major firms is a 50% reduction in carbon monoxide emissions from 120 units to 60 units. Each firm faced the following costs. Firm 1. Total abatement costs equal 2,000 plus 0.6 A1 squared. Marginal abatement cost is equal to 1.2 A1. Firm 2. Total abatement cost is equal to 1,000 plus 0.2 A2 squared. Marginal abatement cost is equal to 0.4 A2. Part A. Calculate total abatement costs and marginal abatement costs for each firm if a uniform standard were used. Part B. Quantify the cost savings associated with a cost-effective abatement allocation that could be achieved through trading. Part C. Write down the market demand for pollution permits and market supply for permits. Part D. Calculate permit price. Part E. Calculate the abatement and emission levels of each firm. Now pause this video, take a few minutes, and solve this problem. Welcome back. Hopefully you're able to solve this problem. Now let's work on it together. Part A. Calculate total abatement costs and marginal abatement costs for each firm if a uniform standard were used. So, to solve this problem, we are using uniform standard. So what does this mean? This means that both firms are abating the same amount. So, let's assume A1 is going to be equal to A2, because that's what uniform standards mean. And we can set this equal to 50. If we do that, our marginal abatement cost of 1 is going to be equal to 1.2 times 50, which is going to be equal to 60. And I didn't write it down, but A1 and A2 represents the percentage of carbon monoxide emission abatement in percentage, and total abatement costs and marginal abatement costs are measured in thousands of dollars. So these are thousands of dollars, so $60,000. And then total abatement cost of 1 is going to be equal to 2,000 plus 0.6 times 50 squared, which is going to be equal to $3,500. Marginal abatement costs of firm 2 is going to be equal to 0.4 times 50, which is going to be equal to $20,000. And then total abatement cost of firm 2 is going to be equal to 1,000 plus 0.2 times 50 squared, which gives us $1,500. And those are your marginal abatement costs and total abatement costs for firms 1 and 2. Now, for part B, quantify the cost saving associated with a cost-effective abatement allocation that could be achieved through trading. So first we need to find the cost-effective abatement allocation. And what is that? Well, we need to set a marginal abatement cost of 1 equal to marginal abatement cost of 2. And we need to have A1 plus A2 equal to some abatement level, some constraint. And we can pick any value really, but we should pick 100 just because then we can see a clear indicator of what A1 and A2 or firm 1 and 2 will abate. So, and to solve this problem, we will use substitution. So let's just do A1 is equal to 100 minus A2. So marginal abatement cost of 1 is 1.2 A1, which is going to be equal to 0.482. Now for A1, we plug in this equation. So we get 1.2 times 100 minus A2 is equal to 0.482. We factor this out or distribute this, and then we get 120 minus 1.282. And then this is equal to 0.482. We move the 1.2 over, so 120 is equal to 1.682 divided by 1.6. We get an A2 equal to 75. Now we can plug in 75 into our A1 equation. So A1 is going to be equal to 100 minus 75. A1 is going to be equal to 25. So firm 1 will abate 25 units, and firm 2 will abate 75. Now we need to quantify the cost savings. So to do that, we need to find a total abatement costs and a margin for old and new values. So the total abatement costs with our new levels of abatement, so total abatement costs new for firm 1 is going to be equal to 2,000 plus 0.6 A1, so 25 squared, and then total abatement costs new from 2 is going to be equal to 1,000 plus 0.275 squared. This is going to be, so total abatement cost of new 1, that is going to be equal to 2,375. And for firm 2, the new total abatement cost is going to be equal to 2,125. So now we just have to add both firm 1 and firm 2 new together. So total abatement costs new for 1 and 2 combined is going to be equal to $4,500. And now we need to compare it to the old total abatement costs. So total abatement costs of old from part A we have 3,500 plus 1,500, which is $5,000. So the cost savings is equal to total abatement cost of old minus total abatement cost of new, which is equal to 5,000 minus 4,500, which is equal to $500 we save using the cost effective abatement allocation. That is the solution for part B. Alright. Now, part C, write down the market demand for pollution permits and market supply for permits. To solve this, we need to realize the emission for from 1, the max from 1 can emit is going to be equal to 60. Emissions from 2 max is also equal to 60. So the total emissions, max total, is equal to 120. The marginal abatement cost for firm 1 is equal to 1.2 A1. This is going to be equal to 1.2 times E1 max, emissions 1 max, minus E1. This is going to be equal to 1.2 times 60 minus E1, which is going to be equal to P1. Same thing for firm 2. Marginal abatement cost of firm 2 is going to be to 0.482, which is going to be equal to 0.4 times E2 max minus E2, which is equal to 0.4 times 60 minus E2, which is equal to P2. And now we can solve for E1 and E2. So to solve for E1, this is going to be equal to 72 minus 1.2 E1, which is equal to P1. Now we can add 1.2 to both sides and then divide by 1.2 and subtract P1. So this will just be E1 equal to 60 minus 0.83 repeating P1. And then for E2 we have 24 minus 0.4 E2 equal to P2. Same thing, we can add 0.4 E2 to both sides, minus P2 on both sides, and then divide by 0.4, and we'll get E2 equal to 60 minus 2.5 P2. Now that we got both E1 and E2 emission formulas, we now need to find our market demand. And to find market demand is just equal to E1 plus E2. So if we add E1 and E2 together, we get 120 minus 3.3 repeating P. So this is our market demand. And our market supply. Well, this is just going to be equal to our constraint from above, which is 60 units, because we're looking to reduce carbon monoxide from 120 to 60. So supply is 60. That is part C. Now part D, calculate permit price. So to calculate permit price, we need to have supply equal to demand. So we have 60 equal to 120 minus 3.3, repeating P. We subtract 120 to both sides, we get negative 60 is equal to negative 3.3, repeating P, divide by negative 3.3, repeating, and we get P is equal to $18.18. That's how much the permit price is. That's the solution for part D. And finally, part E, calculate the abatement and emission levels of each firm. Well, to do that, we already have our emission formulas for each firm. E1 is equal to 60 minus 0.83, repeating, times 18.18, which is equal to 45. And E2, we had 60 minus 60 minus 2.5 times 18.18, and this is equal to 15. So firm 1 will emit 45 and abate 15, and firm 2 will emit 15